Alright, so here's my growth and decay project. To open out, it says a person comes to you and offers you a job working full-time every day for the month of April. She says that she will pay you 1 penny the first day, 2 pennies the second day, 4 pennies the third, 8 the fourth, so on, doubling your pay every day. So would I take the job? I would take the job because the pay is growing exponentially, so after enough time, I would make a solid earning. Number 2, it says, how much will you earn for the first week? Well, you take how much you make each day and you add all of those together, days 1 through 7, and you find it to be 127 pennies or $1.27. Number 3, what is an equation that will tell how much you will get paid on the nth day? And so I said it was a sub n equals 1, our original amount, times 2 because we are doubling every day, and it's 2 to the n minus 1. You have that minus 1 because the 1 here, that is actually after our first day, so you have to do minus 1. Number 4, it is how much have you made after 2 weeks work? So we know it's 127 after 1 week. Now we find all the days of the second week and add those together, plus the first week, so it is $163.83. Is it worth it to have this job? I said it's definitely worth it because after only 2 weeks of work, your daily earnings are already well above minimum wage of Georgia. Because minimum wage of Georgia is $7.50 an hour. So let's say for day 14. Day 14, if we were making minimum wage, it'd be $7.50 an hour. And say we worked the classic work day 8 hours. $7.50 times 8 is only $60. But here on day 14, we made $81.92. Show a calendar with the amount in dollars you will get paid for each day. So day 1, you have the 1 cent. Day 14, we're at $81.92. And then by the end of the month, we are at $5,368,709.12, which is a lot of money for a day. So it says number 7 to make a graph. Well, I actually made 2 graphs. So the first one I made was the pay per day. So you can see it's going up, you're doubling every day. And then the second graph I made was the total pay after each day. So as you can see, day 1 made 1 cent, day 2 we made 2 cents. But at that point you're at 3 cents total, so that's why that's there. And then I went through the whole first week, and if you remember at day 7 we were at 127 cents, so that's what I have at the top. The last part of this one, I would accept this job because in the middle of the month you'll already be making a lot, and as you can see by the end, it was a crazy amount. And let's move on to the next part. So if you take just the last day's pay and put it in a savings account that pays 3% interest compounded quarterly, leaving it in there for 20 years, how much money will you have in the account? So I said A equals the last day, which was $5,368,709.12, times 1 plus our rate, which is 0.03, over 4, because it is quarterly, so 4 times a year, to the 4, which is we have to have our quarterly again, times the amount of time. We said that we were leaving it in there for 20 years. So if you plug that into your calculator, you should come out with $9,760,549.29. All right, here is our graph for it. As you can see in the graph, it kind of looks very linear, but that's just because we haven't had time for it to really make its like peak, or however you want to say it yet, to get in that form. But here are points. As you plug in year after year, like into the calculator, into that T spot, you should get these points, which I put onto the graph. And like I said, it just hasn't made enough years to start looking more like an exponential graph. It kind of looks more linear here. Number 11. So depreciation is a decay. So we're on to this one. Suppose you take the 23rd day pay. So let's go back and look at day 23. It was $41,943.04. and you buy a new car. So use this model to find the value of the car after 6 years if it depreciates 15% per year. So our equation, the original, we spent all that money on the car, so that's there, times 1 minus our rate, 0.15, that's the depreciation rate, to the 6th, so that's our amount, that's our time, and I got $15,818.80 would be the value of the car after 6 years. And then to graph this, I once again put all the t's in and came out with these points, which I then plugged in, and it kind of looks linear at first, but as you can see at the end, it's starting to get its level off, like an exponential graph usually would. So that's my project. Thank you.